just to be able to start grasping the interactions between genes, it is monumental. If something goes wrong anywhere here, even at the level of my muscles, at the level of my neural connections, it's going to be a mess. AI can go in there. And we develop AI not to solve financial world markets, but to solve the fingers moving in coordinated efforts to be able to do the things that we take for granted when we have the ability. So transduction is the process of going from a sensed signal to your perception of it in your higher brain. Transduction is another process just like synthesis. And it doesn't matter if it's the ear, if it's touch, or if it's sight. Transduction is a process that you can explain it in 2 minutes with a few, 2 slides, and a 10-year-old understands. All right, this is how we see. But then you open the box and you say, but how do we really see?
Hello and welcome. The following is a conversation with Mario Romero, Associate Professor in Visualization at the Department of Computational Science and Technology at the School of Electrical Engineering and Computer Science at KTH. His research centers in human-computer interaction, visualization, and ubiquitous and accessible computing. He was also one of the co-founders of BrailleTouch, a smartphone keyboard for blind users, and Anymaker, a tablet application for sketching in 3D. As humans, we have evolved to be sensory creatures that perceive and understand the world from our different sensory receptors. Visualization, therefore, is perhaps the most important means that we have for understanding and making sense of the beautiful yet abstract concepts that our scientific pursuits and endeavors have led us towards. I'm sure as we continue to pursue an even greater understanding of the universe, from data gathered from stars and galaxies to the particles that shape them, the weather patterns of our planet, the cells that make our bodies, or even the thinking machines that we develop, we will need to continue to innovate and find better ways to visualize our scientific endeavors, to understand and appreciate their beauty. Getting to discuss all of these and more with Mario was a true honor, and I'm grateful that he agreed to participate in the podcast. I hope that you enjoy the program.
What do we mean when discussing visualization and AI?
Oh. Early in my career, I was doing AI. I was doing machine learning, computer vision, pattern recognition, classification. And the algorithms, you write the algorithms. Typically in the beginning, you take a paper and you implement the algorithm that is in the paper using the language that you're most familiar with and that works best for you. And it works. And you can see it learning through the results. But the results are the tip of the iceberg, because most machine learning is happening before you threshold an answer. So you want a yes or no answer? Well, you do a lot of work, and at the end you come up with that one bit. Is it yes or no? That was the first place for me that visualization made a difference. I visualized everything that was underwater for that iceberg of decision making. I was doing what's called ADA boosting, and now it's an old algorithm, but at the time it was recent. And ADA boosting is not for Ada Lovelace, as some people may have thought. It's for adaptive boosting, and it's an algorithm for creating a strong classifier from a weighted aggregate of weak classifiers. So you come up with simple rules. If I see a vertical line, there's a whiteboard in front of me. Well, that's going to break most of the time. But then you keep on adding rules to that. Oh, there's a corner, and there's another corner, and there's maybe some whiteboard marker left over. And then you keep adding weak classifiers and giving them weight based on their ability to classify this data until you end up with a strong classifier that is a mix of all these weak classifiers. It turns out that the decision surface grows beautifully towards a boundary where you can do your classification with with good results. So I started visualizing how the decision surface grew depending on each weak classifier being included into the strong classifier, one at a time. And I created an interactive visualization. I created a 3D surface that you could rotate and zoom into and filter. And it allowed me to understand data boosting much better than just the math or just the code or just the results. By seeing the math at work, it made all the difference for me. And that's an example of explainable AI, because I used visualization to explain to myself what the algorithms were doing. And these are not algorithms that I developed or designed. So I still need to learn how they work. And that goes for everything. It may be deep learning. It may be convoluted neural networks. What is more recent, adversarial networks. So we're still working on understanding what is going on inside before a thresholding function gives us an answer. From one end. From the other end, the complexity of data is growing, and visualization is the practice of making data sensible and understandable. And as the distance between the raw data and human understanding continues to increase. And we have started using machine learning to decrease that distance, to bring it back down. So we have a multidimensional problem. For example, we have health data from a cohort, and it turns out that the data itself has 16,000 dimensions. And there are 90 million records, because you may have all the people and then all the tests and all the results and all the follow-up tests. So very quickly you get into a relational database that has millions of records with thousands of dimensions. And you know, as much as we would like to do with the visualization, we can't do that just with visualization. There are too many dimensions, there are too many records. Just to get an overview, it's computationally pretty expensive. And then the power of visualization is to be able to interact with the data. And if you're looking at those dimensions, you can't do it. So you need to reduce the dimensions. You need to do, for example, what's called PCA, Principal Component Analysis, ICA, Independent Component Analysis. You need to have classifiers. You need to find some of the statistical patterns underlying the data so that then you can put a human in front of it and start making sense of it interactively. But not the first original raw data set, but a data set that you have curated through systematic, methodical, and effective machine learning. And all of that, so machine learning will bring in a number of methods, and that's where you need the expertise. So to answer your question, it goes both ways. Visualization helps understand what machine learning is doing, especially before it delivers the results. And machine learning is helping, and AI in general is helping decrease the distance between an ever-growing raw data and a single person or a group of humans understanding what is going on with that data, understanding the patterns and making decisions based on that.
And how important, considering that sometimes visualizing very complex systems maybe just leads to more confusion, is it to find a path that is easy for people who are not necessarily experts in a system that is being used throughout, for example, a whole organization becomes after that?
So we have a number of complex systems that require domain expertise just to be able to understand the visualization. And, you know, given the type of work that you're doing, you may think financial systems are complex. And we have been visualizing financial systems for over a century. And those visualizations have increased in complexity and expressivity. So we're able to visualize more variables at the same time and look at several models at the same time, predictive models of where the market is going. We're also able to look at entire sectors and how they're behaving. We are able to look at the recent past, the longer past, and looking at entire sectors. We're able to drill down all the way to almost the day's transactions on the stock market. and the number of cells, the volume of transactions. And that is a complex system. But it is not the most complex system that we're trying to visualize by far. If you talk to people who are doing genomics and proteomics, the stock market is child's play. And when you look at the visualizations that they're producing for their analysis, just to be able to start grasping the interactions between genes, it is monumental. You have to have an entire career of having been educated so that you just understand the visualization itself. So visualizations are getting specified. They are getting specialized. And the level of complexity in the visualization is increasing, and it is domain dependent. So your question goes to visualization literacy. How readable are these representations for an everyday audience? And to an extent, that's an irrelevant question because they were not created for an everyday audience. There are visualizations that are supposed to target everyone. For example, the New York Times will produce a piece on the voting records of the two candidates that are going against each other again. And they need their visualizations to be interesting, to tell a story, a data-driven story, but to be understandable for their readers. Now, not every human is a reader of the New York Times, taken. But for those who are readers of the New York Times will strive to make their visualizations accessible to that level of literacy, both verbal and visual literacy. But it's not the case when you are solving a proteomic problem. Then you cannot build a visualization that is accessible to everyone without the specific education within the domain. So you target specialists within the domain and you push their knowledge to the limit. And that's how you get actionable insight from domain expertise. Now, if your task is to communicate those results back to a general audience, you need a translation process. And AI may actually help with that.
But even to the experts, especially when we talk about genomics, I think, for example, the work that DeepMind is doing is has been really impressive to see. When the complexity grows to the extent that it has in certain areas, can we even at some points try to visualize, or should we just try to?
No, I don't think you should ever stop trying to visualize. That's almost saying we should stop thinking about it and let some algorithm do the thinking. No. The answer is no. You should always try to visualize it, even if it's incomplete, even if it's sometimes inconsistent. You find mistakes, you find internal inconsistencies in your representation, or incompleteness. You find that it doesn't cover everything. You still need a mental representation, and we are visual entities. We think visually, we process visually.
So the question perhaps becomes, how involved should we be in the work of understanding in the deeper levels? Yeah.
I wanted to finish answering my last statement, so please ask me that question again, because it turns out that even people who are blind from birth are visual entities.
Oh, we have to go into that. How do you mean?
Well, when you read them a story and you put them in a scanner, it is their visual cortex that lights up. When you tell them, oh, and the little girl ran through the forest as the leaves were falling on her cheeks in the amber autumn fall. You read that, and the leaves, her cheeks, autumn, the forest, all of that triggers visual stimulus, even if people are blind from birth. So we are visual entities. We process information visually, even if we can't see.
That's a really fascinating subject to think about too.
We have a huge visual cortex. Our brain is not going to let that go to waste, even if you don't have vision.
That's slightly like a computer that doesn't have the senses to receive the visions, but it has the processing capability.
But it appropriates that part of the processor to do other tasks, or to do the same task in other ways. Because what do leaves look like for people who've never seen them? What does red or orange or the amber autumn afternoon look like for someone who's never seen amber?
Then raises a question that has always fascinated me, and that is that do language models have an understanding of the world? Not multimodal language models, just a language model purely trained on language. It has received hundreds, if not hundreds of thousands of descriptions of, say, an egg.
Yeah.
If you were to somehow just throw an egg as a picture of an egg as like a matrix to it,
Right.
will it be able to recognize that that is an egg?
Yeah, but you're asking two different questions. You immediately ask two different questions. One is understanding, the other one is recognition. Yes, it'll recognize stimulus if it has seen it in its training set. That's what it is trained for. So as long as the underlying statistical distribution of the training set matches the testing set, it can do it. That's what the math says. Understanding is different. Understanding is beyond large language models today. They don't understand what they're saying. We give them the sense of understanding. We
Anthropomorphize.
anthropomorphize, and we, in our minds, say, yes, ChatGPT is understanding what it's telling me to sort of summarize a text. Yeah, it understood the text, and the summary is pretty good. Oh, that's wonderful. No, it's not understanding in the sense that humans understand things. And some of the simplest ways to explain this are, of course, the most basic human emotions and feelings and perceptions. The feeling of cold and hunger and fear and helplessness that someone out on the street on a night that doesn't know where to go may feel. That's beyond. Large language models can say it, but understand it, no.
But my question, when I asked recognition, I didn't necessarily mean a language model or a model that has seen pictures of an egg, but has read descriptions of an egg.
Oh, well, that's a translator. So that depends on the work of the translator. So you have one representation which is verbal, and you have a representation which is visual, and then you have atomic elements like curves and corners and the colors white or yellow, and then you have representations of shadows and surfaces and curved surfaces. So is the language model able to integrate all of those elements and translate them into visual representations and vice versa, and then make sense of new stimulus? It's like an egg is ovoid, a three-dimensional ovoid that has a hard shell, a soft interior when it's raw, and not fertilized, and you can keep on going and give it more and more descriptions until. But the trick here is the translation between visual stimulus and representations and verbal language representations. And yes, you can learn to recognize new stimulus. The large language model can learn to recognize new stimulus if the atomic descriptions of the visual elements are enough. But I guess that's exciting, interesting work that may be going on right now.
I mean, from one perspective, from a computer scientist's perspective, well, at least some computer scientists, it's just matrix multiplications with large language models.
Well, I mean, so here's the thing. When you talk to philosophers and sociologists and people who are working with literature, who write for a living, and their process is the creative, sort of introspective process of creating characters and how those people would feel given certain situations, that is their art. When they see large language models, when they see AI, it's mythical. It is, especially now and in the last 2-3 years, the results are very compelling, and we want to anthropomorphize it and tell and give it sentiment and give it intention. But it's just a mirror. We're reflecting our own intentions and our own sentiments. But it is overwhelming. When you talk to people who have programmed AI, either at the level of using someone else's tools, a tool set, TensorFlow. Oh yeah, I can do TensorFlow. Or you keep on going. People who have developed their own algorithms and perhaps even written papers about their algorithms, proving certain properties, error bounds, predictive power, error bounds on training, and time and space bounds on training, and that type of work. And their life's work is to design and test new algorithms for machine learning. They do not mystify it. There's no magic there. There's no sense of being or intention or feeling. It's like nothing. It's matrix multiplications all over the place, and little weights that are being updated all over the place. So it's very, in that sense, I think everybody should program some small neural network in kindergarten in the future, so that we just demystify the whole thing. Because when you mystify something, you may have unnecessary fear of it.
And yet there are people like Geoffrey Hinton that have basically been behind some of the most important algorithms.
Yeah, I know.
And yet they see a slightly mystic element to their own algorithms.
Well,
not mystic, I would
no,
say.
I wouldn't say
yeah,
mystic.
exactly. But
what
there is
see
something deeper there.
What they see is a potential for disaster. And I agree with that. There are potentials for disaster, but not from the sense of these algorithms somehow developing consciousness and wanting to get rid of humans because we are the virus of the earth. No. Geoffrey Hinton and many other people who are pioneers in AI are concerned about misguided AI, are concerned about goal states that are not consistent with general well-being, goal states that are not consistent with sustainable results for humanity and the world at the same time. So they're concerned with AI being too good at its task, maximizing a function that in hindsight, in the future, we shouldn't have maximized. I think, and that's a solid, real concern, using a tool to push forward an agenda when we don't question the goals of that agenda enough.
And I think that is, the argument for RL loops, that just the paperclip maximizer type of arguments are there. But not necessarily just to focus on Hinton, but both Geoffrey Hinton and Ilya Sutskever, they believe that as complexity grows, there is something happening there that is not anymore just purely an algorithm running matrix multiplications. And I don't know,
but they have an intuition about that. They don't have a mathematical proof or an instance that demonstrates their argument. What they have is a lot of intuition, and their efforts are trying to explain why in this entity has consciousness and a sense of purpose and a sense of being arising. Why does it exist in this entity and not in this other entity? What is the difference? So because we have many examples of animals or central nervous systems that exhibit intention, emotional states, goal states, problem-solving capabilities, not just humans. There are tens and tens of animals that exhibit all of this levels of intelligence. Probably not even tens. It's probably in the millions of species. If you expand your definition of goal-seeking agents, it's all over the place. So why is the central nervous biological system able to exhibit that behavior to the point that it has a sense of self and intention? Now that one is more restrictive. We haven't seen a sense of self in every species or in many species. But the big question is, what is intrinsically different about this system versus the systems, the mathematical systems that we're defining to produce goal-seeking, intrinsically intentional, self-aware systems? Why are these failing and this work? So that's a pretty solid question. And yes, there is complexity in the code, there is complexity in the architecture, and that complexity is increasing, and it is tempting to think that it is a matter of scale. At this scale, so at this simplified scale, abstracted scale, we will not see intentional beings, like intrinsically intentional beings, arise. But if you just increase the scale, you will eventually see intentional beings arise. And that's a huge, at this stage, it's a huge philosophical discussion. So you can go in, and Roger Penrose, for example, will say, no. To get intentional beings, you need quantum mechanics. It's like the brain is actually a quantum machine. So when you start modeling at that level, we don't have the expressive power to model that. Like, it's nowhere near the horizon. So if it does matter that this quanta went that way, or is communicating at a distance with this other quanta within the brain, that's way beyond what we can model with our computational power today. So it really depends who you're talking to, and there's a lot of speculation, and there's a lot of intuition. I guess I have my opinion within all of these discussions, but I am a pragmatist, so I don't think the question matters.
I shall now question how much of a pragmatist you are, because we previously had a conversation that fascinated me very much. For those listening, we had a conversation after a TEDx talk that you were giving, and you told me at the very end of it that we should respect AIs when we talk to them.
Oh yeah.
And I thought about that a lot, as I do respect AIs just because I think the way I was raised as a human being, I always am thankful to them when they do something for me. But when I think about it, it's just me anthropomorphizing. Especially even weaker AIs, not large language models, but when I use Apple's Siri, which is now getting an update, but nonetheless, the very machine learning type of algorithm, I know I can code how that works, and I have an intuition of how that works. And nonetheless, I have a sense of respect for it. But why should we have any sense of
Well, there are many
respecting?
reasons. There are many reasons. And I'm going to go super simple. When you bring me this glass of water, I need to be careful with it. I don't want to spill it. It's just practical. So I treat it with care. I have a laptop. In this case, it's a tablet. I need to maintain it every now and then. Laptops more than tablets, it's amazing. But defragment and clean stuff up, get rid of old files that I'm not using anymore. Make sure that everything's backed up in the cloud. That's treating your laptop with respect. When you disrespect your laptop, it will start failing on you. You have too many processes going on. You're not cleaning up your memory as much as you should, as often as you should. You're not backing up your material as often as you should. And there will come a point where the disrespect of your laptop, the misuse of your laptop, will come back to haunt you. So there's a practical reason why you just should treat things with care, because they will last longer. I like to bike. I got to treat my bike with care. It's not that they have emotions. I don't care. I just want it to work, and I want it to work as best it can for me, for as long as it can. And when it doesn't work anymore, I'll recycle it and get a new one without any emotion involved. So I'm not anthropomorphizing it. So that's the first answer. It's just practical. The second answer is just good practice. It's good manners, and it's good to practice good manners. I don't think it's a good idea for us to have chats with ChatGPT where we are anthropomorphizing our sense of its understanding of what we're saying, and yet we are ordering it around, like if it were a slave. That's not good practice for humans. On the one hand, you think it thinks, you think it's intelligent, and then on the other hand, you're treating it like crap, like a slave. That is not good practice. That is not something you want to get into people's minds. You should never treat an entity which you think is intelligent anywhere lower than you would like to be treated. If you think it's intelligent, just treat it with respect. And that's the second. It's not as practical, but it is commonsensical. Humans, we are creatures of habit. Develop good habits. Treat entities that you think are intelligent with respect. I mean, we do treat animals that we know are intelligent with care, respect, and love. And when we don't, we're inhuman about it. The third reason is it's actually it's a philosophical reason. If the entity that you're engaging with exhibits all the features of intelligence and you cannot tell that it is not intelligent, it is just common sense, and be on the safe side, treat it with respect. You have nothing to lose. And yet if you don't, and you have no way to prove that this entity is not actually intelligent and has intentions and desires and an internal state of mind, and you're still treating it like a slave, we're committing this pretty much the same ferocity of the past. That's it. We are just degrading ourselves.
Has a slight tone of Pascal's Vega to it.
Yeah.
But no, I think like the question of like morality in the sense of it is kind of draws on the works of Immanuel Kant as well, just in terms of being a morally good human being. And
well,
yet
it's an intrinsic value. That's the thing. We don't need an extrinsic validator for doing the right thing. We have moral organs, most of us. And when we don't, we may be dangerous. When we have a pathology that limits our social understanding of a situation, our empathy, we are sociopaths or psychopaths. And some people recognize it, they've been diagnosed, and they live normal lives within the boundaries of what they can distinguish and not. But some people are not diagnosed, they're not treated, they go through their lives and they become very, very, very dangerous, because here you have a thinking entity without empathy. That's a very dangerous combination.
But don't you think that we are perhaps actually worryingly slightly moving towards that path with humanoid robots? That's
of course, that's it's a super dangerous combination to have a thinking entity with internal goals and internal representations and states that self-assure itself without empathy. So that is, without recognizing that other thinking entities will have their internal states and goals and have just as much right to achieve them as this first entity has. Then you get pathological entities, like sociopaths, literally, and that's dangerous.
That's a slightly not very optimistic tone for the future of humanity, I guess.
Well, no, I have no, again, I'm very pragmatic. What it means is that we have to be careful. We have to build empathic machines, not just thinking machines.
Yeah, I mean, at the moment, I think like all the big companies that are working on humanoid robots actually kind of try to avoid giving these robots any faces, because they don't, I don't know why exactly, but they don't really like the idea of making them.
I know why. When you give a robot a face, you have to make a decision how realistic is that face going to be and how expressive is it going to be. And if you go anything beyond cartoonish, it falls into the uncanny valley, and people's perception of that face is negative. It's not positive. So people will not have a good perception of this robot that almost looks like a human, but it's clearly not a human, or a dog or whatever other real faces out there. So rather than do that, they either keep the faces completely out, or they put very cartoonish faces with big round eyes and clear expressive states, but stay completely away from trying to look natural, because that's a problem. But I'm not talking about that. I'm talking about and I'm not even talking about robots. I'm just thinking of, notice that I say the term thinking entity with internal states and goals. That is my definition of an entity which you should respect, regardless of whether or not you can prove it's intelligent and has consciousness. We don't even know what consciousness is. We don't even know if we have consciousness. We think we do. So you have this entity which may be material, it may be a small robot, a big robot, or it may be immaterial, it's code in the cloud. Regardless, that doesn't matter. The fact that it has a physical representation and a body, of course it makes it a potential physical threat, but that's very Hollywood. Threats can be just as devastating even if they're not physical. And my point is that when we're designing entities that think and have internal states, we have to include as one of those internal states the knowledge that there are other thinking entities with internal states and that some negotiated balance needs to be reached when maximizing its own internal goals. The game of life is not won by only maximizing your own goals. Everybody who attempts that ends up eventually being destroyed by everyone else who sees it as a pathological entity, a sociopath. So eventually the rest of the thinking entities will gather together and take it down because it's just pathological, it's a cancer. And this has happened over and over again in the history of humanity, and it will probably happen again in the future. When you have a completely selfish being, it cannot function in society. So we cannot build machines that are completely selfish, completely unaware of the fact that there are humans with its own internal states, and there are other machines that are intelligent that have their internal states and goals. That's what I mean by empathy.
It is one of those questions that I think needs really broad societal discussions. And moving on that theme, actually, moving slightly back to visualization, we mentioned the fact that it can be slightly hard to visualize complex systems for the layman. How important do you think is to visualize the inner workings of, say, large language models for the broader public to make them understand it?
Okay, so you need a level of abstraction. So and you need to think about who is the audience and what the goal is. So the audience, let's say, is everybody, 5-year-olds, 10-year-olds, and the goal is to explain how this is not magic. So you have some room to explore and express yourself there. So think about it. The population is 5 to 10-year-olds, so these are grammar school kids, their age, and there's a huge difference between a 5 and a 10-year-old, so that's a pretty large range. Let's narrow it down, 8 to 10. So they have started reading language, they are very comfortable in spoken language and visual literacy, they can read signs, and they've started with math, arithmetic. They've, by 8, in fact, they've dominated basic arithmetic. And I'm talking about neurotypicals, so sort of the curve, the bell curve, within reasonable bounds. And try to explain to these people what a large language model is doing, what a generative AI model is doing. What is a deep neural network? What is a convoluted neural network? What are the difference between them? I think you can, using a language that they will understand, but most importantly, a language that will demystify. And I think that's super important. And the generation, so the 8-year-olds of today, they really need these lessons because these machines are not mystical. They are not. They are just machines. It is just math at a very large, convoluted, expressive level. But again, it's most of it is arithmetic, in fact. Just in sequence and different orders, but most of it is arithmetic. And I think that's super important, and I think it's doable. And I have seen some efforts out there of different groups visually explaining how these algorithms work. It's very shallow, but it demystifies. And it's shallow in the same way that you would explain to a 10-year-old how photosynthesis works. Well, the sun and the leaves and the chlorophyll and energy. A 10-year-old would walk away from a visualization of photosynthesis feeling they've understood it, they got it. They know it's the sun, it's the rays, it's the leaves on the plants. When you look at the metabolic processes of photosynthesis, your jaw will drop when you go down into the atomic level. The molecules and the photons, it's just like, it's mind-boggling complex. He's like, just, give me some AI to try to process this. You don't do that with a 10-year-old. But the 10-year-old still walks away feeling that they've understood photosynthesis. We can do the same with all of AI, because none of AI is as complex as photosynthesis.
Yeah, exactly. And if we move slightly to a technical level of visualization, what's the right path of understanding what classifiers and weights are the ones that you have to choose or give the greater weight to be able to make good visualization?
Right, so we're going into explainable AI and trying to open the box. And that's the $1 million question, because nobody knows. We would like to know how a classifier, how a perceptron, how a neural network, how a deep neural network is forming its decisions. And we would like to see the evolution of connections between elements of the model and how those are being strengthened or weakened, and how the systemic behavior of the entire model produces behavior that is indistinguishable from intelligence. And yet somehow it is escaping us. We do model the weights, but then the network gets complicated. The architecture gets deep enough, or the number of nodes get deep enough, and the number of connections gets large enough. And then just to run the models, it takes hundreds of hours on supercomputers. So most of that runtime learning is thrown away because you don't have the bandwidth to save it and analyze it later. So we have like a super interesting problem. These models are consuming a lot of processing in order to generate the type of behavior that we consider intelligent, and most of that processing needs to be thrown away because there's not enough time to take a second of processing and save it into hard drive. I'm not even talking about space, just time. Because as you know, the levels of memory get increasingly expensive as the permanence of it increases. So you want to keep a good snapshot of what the model was learning at step number 13. Well, that's going to be a huge cost. And if you want to do that throughout the model, forget it. So we've cornered ourselves into not understanding, because we've created models that are so complex that we can't analyze them as they are being trained. Not at the level of detail where we could start getting some understanding of what is going on.
Yeah, that's a really fascinating question of just creating something that you yourself can't necessarily help others understand, even though you kind of have it's kind of quite similar to the photosynthesis, is that when you zoom out, you kind of can put a shape to it, but when you try to zoom in, it really becomes...
It becomes too expensive for you to try to understand it at every step of the process. Do you know how much it cost to train ChatGPT 3.0? Have you seen those numbers?
Yeah, I don't actually remember now, but it was something of billions of dollars, I think. Scale.
It's in the millions.
Oh, was it? Oh, right. Sorry. Now, the current new state one is estimated. I mean, they're building $100 billion supercomputer, but that's a...
Well, that's a supercomputer, but then you buy time from the supercomputer.
Yeah, exactly.
And supercomputers last 4 years. So if you have a supercomputer that is $100 billion US dollars, and you know that in 4 years it's not going to be a supercomputer anymore, because that's the rate of progress for these machines. And if you take a month of that machine to process your neural network, that has a cost.
I think it was $100 million for 3.5, right?
Yeah. Exactly. Right? And that's the money. And then there's energy, and there's And some people are using these machines to predict weather patterns so that they can understand climate changes better. So we're putting these machines that are finite resources into, ChatGPT, taking away some of those finite resources from global warming, because it's a delegation problem, it's a maximization problem, because we cannot be using these machines infinitely. Time is limited. The lifespan of these machines are extremely short. So yeah, 350 million. That's what you said.
I think it was 100 million for 3.5.
100 million for 3.5. So you train a model that costs $100 million to train because of the resources, the supercomputing, the energy, etc. There's also human time. And you get, the training the model is like recording a movie. Think about it like that. You record a movie at 60 frames per second, 4K, beautiful, for a month. And then in the end, you grab a set of pixels from that movie, like the center column, and you take, at every step you've been saving that center pixel. Let's say that the center pixel from that movie, that 4K movie. You take the center pixel and you save it. Take the center pixel and you save it, and then you generate this huge vector. And you throw away the rest because there's no time to save it. It takes time to save that 4K frame. Like, it could be 10 milliseconds, but you don't have it because that's how fast this thing is going. So, and it takes space, because then you'll need a farm of disks to store all of this. So you take that center frame and you throw away the rest. That center pixel, you throw away the rest. And that center pixel is your trained model. And everything else of that month-long movie is gone forever. You don't know what happened. How, it's so frustrating. How can researchers go in and understand what these things are doing if it's impossible? Because these models are so large and the computers that they are being trained on are so powerful that just to get a snapshot of what's in RAM is too expensive. Because it's got petabytes of RAM. I don't know how much RAM they have. But just the RAM is just like, oh my God, I'm going to need a farm of hard drives just to save a millisecond of RAM. What's wrong with this? So we have that conundrum. We can't really access the training. It's beyond us.
That's perhaps another problem of people, the general public, having to understand like the scale of the, like, just even when you write a prompt, any prompt to ChatGPT, you're sending it basically to this GPU farms to like process it.
Yeah.
And you can do that with a search engine that costs much less in terms of like energy and its environmental impact. And yet, if we don't have that understanding, which I think many people perhaps don't necessarily have an insight into it, it's a question of convenience.
Right. I mean, I've been talking to people. There was a fad. There was a wave of people chatting with ChatGPT. It's like, oh, I've chatted with it. And I don't know the numbers, and I would love somebody to do a proper survey. But how many people are still using ChatGPT productively? How many people have built plugins where they either bring ChatGPT into a larger app, or they take a task and turn it into an app for ChatGPT, and they're writing those little plugins, and they're making it work. It's super exciting. So how many people are using ChatGPT for productivity? Continued. I don't know. And 3.5 is free. 4.0, you get a few hours for free every day. And you can pay the license for 4.0, which I think is like, don't tell me, I think it's like $25 a month or something like that. It's like nothing. I mean, for people that have a job in the developed world, that's like lunch Tuesday and Wednesday. That's how much it is. Again, there is a digital divide that we're not talking about, but $25 may actually be a substantial amount of money in different parts of the world. But regardless, then in those parts of the world, having a computer that is working most of the time, electricity that is working most of the time, and internet that is working well most of the time is also a luxury. So there is a digital divide. But this thinking, this proposition, this idea that you're introducing into our conversation, that are people aware of the resources they're consuming when they're having philosophical discussions with ChatGPT? They're like, how much is this costing the planet? How much energy are we consuming? What is the carbon footprint of your conversation? No. It's like, whoosh. No. It's free for people. People assume it's free. It's part of our digital exhaust, and ChatGPT has joined the digital exhaust. All our data is like everywhere. All our sensors. I got this. I got that. I got this. I even got this. Like the alarm. It's not connected to anything, but still. This one is a good example. This is just a magnetic key to open my building. And if I were to lose it, I would send the number of it to our building administrator, and he will cancel it immediately and issue me a new one. So digital exhaust everywhere. We're producing terabytes of data which is wasted, and we're not aware of it. And the problem is that many servers are keeping it forever. So we should be more aware of the things that we want deleted forever and from everywhere. So that not only for security and privacy reasons, but just for, good citizens, being a good citizen. Just throw away the garbage, burn it, return it to the universe. Return those atoms to the universe.
But I mean, the thing is that should we strive to understand them as a society?
Understand who? The algorithms? Or
not necessarily, just the scale of data that is being stored and processed.
I think we should be aware. And again, this is a conversation we should be having with 5-year-olds. Just as we have the discussion about recycling and separating the garbage, glass goes here, cardboard goes over there, let's be good to the planet, and generate a social consciousness of recycling physical things. We should generate social consciousness for recycling digital things.
But then that question becomes, I held, just as a preamble to the question, I held a number of short lectures about diffusion models to a group of students at the Royal Academy of Arts in Stockholm. And it was truly a challenge to make people understand how large language models with diffusion models work, to be able to generate pictures. So especially the noise and denoising part, because it's kind of counterintuitive, is hard for them to understand. And yet when, in the end, we had gone through the process without necessarily going too deeply into the mathematics, what I did was basically I took snippets of a diffusion model, pushing in noise and then denoising that picture stage by stage, and showed it to them. And after giving them a few examples, I truly think that they developed an understanding of it.
You visualized it.
Exactly.
You visualized the process step by step in discrete steps, and not every step, but carefully selected advances, so that the difference could be clearly visible. Exactly. So you showed them, and their response is, I see.
But
meaning they understand.
When we have a humongous levels of abstraction, can we maybe start using AI to? And that's actually becomes a question of how well does an AI understand us, or maybe it doesn't have to really understand us, but start using AI to create these levels of abstraction in a way that it creates a path for us to be able to visualize things, because we maybe ourselves wouldn't be able to do it. When you're generating one picture, it's of course not that hard, but when you're talking about really huge structures, maybe
I definitely think we should start using AI to visualize AI. Definitely, we should allow them to check themselves. We this is what I'm doing, this is what I'm thinking. We definitely need to have a process where an AI gives a user an answer, and the user should be capable of asking, how confident are you? How did you come up with that answer? Show me. I don't understand what you're saying. Those words don't mean anything to me. Draw me a picture. Oh, okay. What does that mean? Oh, and what is that? Say it in a way that I can understand. No, I don't understand that. Go lower. Go lower. Keep it simple. Say it to me like I'm a 4-year-old. And we should definitely have that. Because if we consume answers, if we consume the results of an AI without questioning it, we're screwed. That's it. Game over for the human. And the reason is because you're at the most dangerous state. You know you don't know. You know. You're at the state where you think you know, but you actually don't know.
That's the Dunning-Kruger effect, as they call it. So,
because you've received an answer and you trust the sender, and actually you shouldn't have. You shouldn't have trusted the sender, so you should have questioned the answer. So now you're in a state where you think you know the answer, but it's incorrect. Because you can be in the state that you don't know, which is complete ignorance, and the state that you know, and you truly know, and that's complete knowledge, at least of that one phenomenon that you're studying. But there are other states in between. And being in the state where you know, but you actually are incorrect is probably the most dangerous one. You haven't verified. You haven't taken the step to verify. So you think you know, but you actually don't.
That is perhaps the dangers of the lower education levels. Just, as you mentioned, the photosynthesis, I think that's a good example because...
Photosynthesis is a beautiful example because you can go crazy. You can go quantum with it.
Well, I mean, the general knowledge that a 5-year-old or 6-year-old gets at the first year of school about that is very simple and in perhaps some ways not even entirely accurate. But it just...
Oversimplified.
Exactly.
The simplification can be smack down the middle of where the reality lies, but because it's oversimplified, it's almost meaningless.
That's the challenge of it then.
Do you know what transduction is?
No.
It's the process of taking a phenomenon like you clicking the pen and me hearing it. My ear transducts the signal, the waves in the air, and my brain processes it. So transduction is the process of going from a sensed signal to your perception of it in your higher brain. Transduction is another process just like synthesis. And it doesn't matter if it's the ear, if it's touch, or if it's sight. Transduction is a process that you can explain it in 2 minutes with a few, 2 slides, and a 10-year-old understands. All right, this is how we see. But then you open the box and you say, but how do we really see? How do photons generate images in your mind? I mean, how does that happen? And then you open that box. Oh my God! Oh, you close it immediately. Oh God, you just saw this crazy metabolic process that actually takes a photon hitting a molecule, bending it, that molecule being accumulated in the retina, producing a signal, and then bending back. And a cycle that is happening super quickly. So when you open enough boxes, it's like, oh my God. And you thought you understood, but then you go all the way down to the nitty-gritty atomic level, molecule level detail, individual photons reaching your rods and your cones in your retina. And what happens in there once that photon has gone through your eye, and it actually goes all the way to the back of the eye through the blood vessels, a lot of stuff in between, and reaches your light receptors. Understanding that in its full glory detail is really, really deep. Again, just like photosynthesis.
I mean, there is an interesting type of story that has popped up recently. I don't know if you followed the Terrence Howard redefining physics.
I haven't. Tell me a little bit about it.
Yeah, there was this actor in the US, Terrence Howard, and he went on the Joe Rogan podcast.
Yeah.
and he basically has kind of redefined physics and mathematics.
All right. What's the new definition?
Well, basically, one of his new definitions is that 1 + 1 is 0 or something like that.
Okay.
And the funny thing about that is that many people now have and he's written a book and he's published it.
All right.
On his new definitions of mathematics and physics. And the
But
concept.
what's the purpose of redefining 1 + 1 = anything other than 2?
Well, I mean, not to go too much in details on something that I have to say. I haven't sadly read the book, or happily. But what has occurred is that a humongous number of people on social media have now started saying people should listen. People in physics have been like ignoring these people like Terence Howard and listening to them. And
I love provocative statements. And I love people that provoke the status quo through provocative statements. If this is what Howard is doing, go for it. Provoke a reaction.
But I think what is happening slightly more like the ideas of Nikola Tesla in the later stages of his life, for example, about radio waves, that they are basically just electrons moving through the air, rather than just sticking with the status quo of the scientific beliefs that are still present. There is this worrying factor that is occurring, that people who think they know something start coming up with ideas. And
so I don't know about Howard. I know about Joe Rogan, and I know sort of some of the conversations he has with guests. There's a danger. There's a danger in misinterpreting a provocative statement versus an idiosyncratic statement. You think that's the way it is, like the earth looks flat and it doesn't make any sense that it is not. Therefore, the earth is flat. That's an idiosyncratic statement. You don't have any evidence for it, but yet you defend it. And then that, complicated by the fact that people misinterpret democracy as well, and they think that democracy is doing whatever they want. I'm free, therefore I can do whatever I want, and I can think whatever I want. So you confabulate those two belief systems, and you get super dangerous states of mind. And these people that are sure they know this thing that they are talking about, and the value of rigorous evidence and methodical work is overseen completely.
But this brings us to a conversation again that we had about science fiction, and that worries me. The reason I raised this was that people have this type of perception towards AI.
It is. There should be an AI flat earther society. It should be something like the Killer AI Society or something like that. Or the Society of AI Making Humans Irrelevant. Or something in that line. Yes, I agree.
So, and I have had one time we had a conversation with an ethicist on the podcast, and we came to the conclusion that everyone at school should at least learn some, as we mentioned, programming, at least a very simple language.
Not just everyone. 5-year-olds should
exactly,
be
it should be part of the school curriculum.
Logos or some very visual language that allows them to put pieces together and program behaviors. If I see this, turn left. If I see that, turn right. Lego Mindstorms. When I went to high school, I didn't learn about particle physics, and I did not learn about quantum mechanics or ions. Not even that. What is an ion? I didn't learn that in high school. My kid is learning that in high school. He's learning, again, not at the depth that somebody who's doing the research on quantum mechanics will get, but they are learning about quantum mechanics when they are 16, 17. So the need for humanity to demystify AI is even greater than the need to understand quantum mechanics for our everyday existence, for our everyday life. Having said that, grammar school kids should also get a course on balancing your finances, diversifying your portfolio. I mean, perhaps not at that level, but just so, for example, the value of having a financial know-how. What is savings? The biggest one is the exponential effect of interest. That's like human minds are not very good at exponentials. So 2% every year is not 20% in 10 years. No. You have to do the math, multiply it every year and get it. Kids need to know that.
And maybe as we are visual creatures, AI can assist us in, like, I genuinely think like AI is one of the best things about current large language models is their capabilities in education. Maybe that's a path forward for that. But moving the conversation to developing better AIs, why is multimodality, do you think, important? Or is it even?
Is it important? And if it is, why? Of course it's important, because we are multimodal and the universe is multimodal. In fact, we actually only perceive a narrow band of the universe with our senses, the ones that we evolved. We have had to build machines of all sorts of types to understand that the universe is much wider and broader and deeper than we ever realized with the eyes on our face and the ears in our head. So of course AI needs to be multimodal because the universe is multimodal, and if it's to operate in a real universe, it needs to be multimodal. If it's to interact with humans and ultimately with other AI that is multimodal, then every AI needs to have a concept of multimodal. Not every AI needs to be multimodal. They could be AIs that are purely abstract and mathematical, and they're focused on this one task. But when they're interfacing with the larger system, every AI should have the concept that there are other entities, again, a sense of empathy, that actually have a multimodal experience of the universe. And it may be the case that part of acquiring a sense of self and an intrinsic value of self and an intrinsic system of states and goals and intentions, it may be the case that it is emergent from the multimodal brain that we have. I don't know if there's any evidence of that. But there's evidence that we are multimodal and that we have these internal states and drives. So I think it's just a good idea. It's more complex though, because most of AI that actually works sticks to one thing. So yeah, it's a harder challenge.
And what are if we go a bit more technical into that question, what are the pathways that we can make them multimodal?
They're expensive, that's for sure. I mean, if training a language model is $100 million, then training a machine that understands what it sees, what it hears, what it touches, what it creates, and its effect, the emotional effect it has on other thinking entities. I can't even begin to think what the cost of that is going to be. The combinations, and that's the. I should say that is the function that keeps computer scientists real, are the combinations, the combinatorics. When you look at the possibilities, oh my God, you can wait for the death of the universe to be able to compute some stuff. So the combinations in every multimodal state and stimulus and in the learning process, I have no idea. I have no idea how complicated it's going to get a truly multimodal system at the level of ChatGPT 3.5 for the other modalities at the same time, because it's not linear. The combinations are multiplicative, at least. if they're not exponential, and then we're screwed. but but they're at least multiplicative. So that means it's suddenly $10 billion to train a multimodal system, that an agent, a model that behaves like ChatGPT for all its other modalities. And I really have no idea how you would go about training that, how you would build the math basically behind it. But I do know it's going to be super expensive. That's, it doesn't take an expert. You can see it. And then the question is, what is the value? So if we are willing to spend that much money and resources, humanity's resources, to train these models, these systems, what value those humanity get back? And not just, and hear me out. Most of AI today is driven by profit. And I think that's a mistake for humanity. Remember at the beginning we talked about that function that you're maximizing? Most AI is maximizing money. And money is actually, if you think about the species, money hasn't existed for a very long time. If you think
I mean, I think in the terms of like the modern human being, it has always. But
the modern human being is over 250,000 years in the making. We became Homo sapiens that long ago. And we've had money for
10,000 years?
Something like that. Oh. Agricultural Revolution, Babylonia. Here you go. Here's a representation, an abstract representation of value that you can trade for something else. It's overcoming bartering. That's nothing. In evolutionary terms, the 10,000 years we've been using money is nothing. We have been Homo sapiens for 250,000 years. 10,000 years is a drop in the bucket. Maximizing money is a mistake.
I mean, do you think that we will one day, perhaps through AI, I mean, the numbers that people throw around these days are, of course, extremely speculative, but many say like hundreds of trillions of dollars added to world's economies and, you know, automation.
Well, you're still maximizing money. And that's a mistake because it's simplistic and it leads to suffering. Wealth distribution, inequalities in wealth distribution, digital divides, the rich get richer. It's a mistake to just maximize money. I'm not saying don't make money or don't maximize money. What I'm saying is think about the larger picture. Money is a means to an end. It's not an end in itself. Wealth distribution matters. Not just internally within countries. And by the way, countries are an invention that is even like very brief. This thing that we call Sweden, in its current state, it's like 200 years old. In its former states that were very different from the current state, maybe 1,000 years old. That's nothing. The US, 200 years old, it's nothing. So this concept of nation states is also very ephemeral. So when you think about money, you shouldn't think about it as a goal, and that's the problem that all the big companies that are pumping money into AI, that is the goal they want to get out of it, because they got their shareholders and stockholders, and they want to show the profit of the investment. So they're working on return on investment. That's what they're maximizing, and that's a mistake. Because on its own, if you leave it on its own devices, what it does is it congregates, and it accumulates on a very, very, very few hands, and without a proper goal, which should be, I don't know what the proper goal is. I have no aspirations to know what the proper goal for AI and humanity should be. But my intuition tells me it has more to do with justice than with money. It has more to do with equity than with maximizing profits. It has more to do with compassion than competition. We are not, in my opinion, we are not humans because we are competitive and we can win and we can kill the competition. Other animals can do that better than us. In my perception of the world and of humanity, we are humans because we're compassionate, because if somebody falls during the race, every now and then there will be somebody that stops, picks them up, and runs with them at the cost of their own winning. We are humans because if a member of our species breaks their leg, we stop what we're doing and it doesn't matter. You know, nowadays we make a phone call and cancel our meetings, but we are with them. We keep their body warm. We call emergency vehicles. It just doesn't make any sense for a non-sociopath human to not stop what they're doing and provide care, compassion. That's what humans are. Other animals are better at winning. Other animals are better at taking out the competition. Not even animals. Other entities are better at taking out the competition. Viruses and bacteria are better than humans.
I think Peter Kropotkin, the Russian aristocrat and scientist and also anarchist, had a very interesting book from his studies in Siberia just about that, because in the beginning of the 1900s, everyone was going on this social Darwinism path of thinking that animals are just eating each other out. But even they have this type of a symbiotic type of life between each other, of helping each other. And
some species.
Exactly.
Some species. But yeah.
Even between, if it exists between, I mean, not that I'm saying downgrading animals, but it exists in nature and it exists in us. And I think it's something that in most cases makes human beings feel like human beings. It makes them feel good when they help each other out.
Well, the thing is, it's embedded into our genetics because the future of humanity is not super individuals. Forget about that. Perhaps in sports, you know, the next Usain Bolt, the next Michael Phelps. Those are super individuals, and yes, we are pumping resources into educating and training and producing super individuals. But as a species, that's not what we do. In fact, as a species, what we do is we pool the resources of hundreds of thousands of people to allow this one person who won the genetic lottery to shine beyond what is humanly possible for everyone else. It's the resources of hundreds, if not millions of people that allow this person, this group of people, to exploit their genetic lottery. The talent they have, the length of their arms, the length of their legs, the symmetry of their structure, the power of their strides, the power of their strokes.
I think that's an inherent human factor of loving heroes, generally speaking.
We love heroes. But the real hero of the story is that heroes, unlike the movies, are the product of
a collective
social movement. And it takes an entire universe of thinking entities with their own personal drives and goals to align themselves to this one hero and push them beyond what is humanly possible. That is what defines humanity. We are evolving not to be super individuals, but to be hopefully a super collective that can choose where it places its resources so that some individuals get to carry our dreams. It can be an astronaut, it can be an athlete. But we pull all those resources together and we leave aside some of our own individual goals and our own individual drives and states in compromise and through empathy with the collective and willingly. That's the beauty. It's not like in Star Trek you have the Borg who have the collective and they are mindless drones.
I actually wanted to ask you just about that.
Yeah. So it's not that type of collective. Humanity is a collective where every individual has their own goals and their own states and beliefs and values. And yet they place part of their resources above themselves towards a common goal. That's humanity. And when you're maximizing money, you're not maximizing humanity. You're maximizing individuals, the super rich individual, or small group of individuals that control the algorithms. And that's a fundamental mistake of the current landscape of AI. We have to stop that. We have to stop that. It's not about money. It's about that which defines us as a species. It's compassion, it's care, it's being able to place other people and other entities above yourself, even for a fraction of a day. You're driving down the road and a biker gets hit by a bus. You stop and you give care, even if you had a very important meeting that day. That's what defines humanity. And maximizing money doesn't take care of that particular problem at all. You can't stop and give that person, switch that person 1,000 crowns. All right, get better. It doesn't make any sense. It doesn't make any difference. The money is useless when you're on the street losing blood or body heat. And what you require is actual human attention. Of course, in the end, it's going to cost money to make it all happen. But money is a means. It's not an end. It's not a goal.
And maybe as we move perhaps to, just because it's a conflict.
Between, of course it's a conflict. How are these companies going to pump in billions of dollars to create these models if they don't get billions of dollars, trillions of dollars back?
Exactly.
I know.
And still, they're not really making that much money on LLMs yet, to be honest.
Yeah, I know the promise is there, but there's a lot of potential. There's not enough fruition.
But what many people think is that basically overabundance of money will lead to...
Well, that's the trickle-down effect, and we know it doesn't work. Overabundance of money will not translate to everybody having a basic universal income. No. There needs to be regulations, there needs to be laws, and for that people need to agree and place something bigger than themselves above themselves. That drive... The thing is that when you're on the road and you see an accident and you stop to provide help, it is so tangible, it is so concrete. But when we are living in a planet where millions of people are dying from mosquito bites, which are preventable, nobody stops because it's abstract, it's not concrete enough, we don't see it, it's not on our way to work. We can use AI to create systems that actually are able to transfer resources from places that, like donations and foundations and racers, but in a much more efficient way with much less going into administrative work, for example. All of it going to actual help. That's a use for AI that is maximizing the value, the social value of money, but not money. And it may sound like a subtle difference, but if your function is money, if you think about it long enough or short enough, however you want to see it, you're dehumanizing AI. Like, really, you're dehumanizing AI. And humans who work only for money have dehumanized themselves. I'm sorry. If you work only for money, you have dehumanized yourself.
Yeah, it kind of... Yeah, I shall not judge people, but yeah, it kind of feels...
Dehumanizing is not that bad if you think about it. It's not like you're a monster. It just means that if money is your only goal in life, you have given up on compassion and empathy and justice. And you can be morally fine with it. You're not being unjust to other people by not stopping and helping them within your moral system. Some moral systems may say, yes, you are, because you have the means, you have the resources, and you had an opportunity, and you still didn't do it. So it depends on your moral compass and your system of values. When you create your system of values, and the problem is that when you start maximizing something like money, very quickly your system of values starts adapting to justify your actions. And that's a slippery slope. So be careful. Have a solid system of values before you start maximizing money, and then go out and start maximizing money, but know when to leave the game. know when to, what is your stopping function? How do you, and then let's say you go to Las Vegas and you're going to maximize your profits by gambling. A good gambler will have a stopping function. After this set of conditions are met, I will stop, no matter what. I don't care if I think I'm going to win in the next round. I will stop. That's a good gambler. A bad gambler is the one that doesn't know when to stop.
In the end, we come to Kenny Rogers. I don't know if you've heard that.
I don't know about Kenny Rogers' life. I know who he is. What happened with him?
He has a song, The Gambler, basically.
Oh, The Gambler, the song, of course.
So at the end, we come to the famous lines, you got to know when to hold them.
Yeah.
And when to fold them. So
exactly. So you have to be, well, the thing is, you have to think about this and form a system of values before you join the game. And then you have to be strict and disciplined to follow that system of values while you're in the game. Because the danger is in modifying your system of values while you're in the game, because your state of mind has changed significantly. So please remember your system of values, the one you decided on before the game was introduced into your state of mind. Please remember that before you start changing it in the game. That's dangerous.
I think the trick is basically being able to be a spectator and a player in the game at the same time. Because when you are...
Detachment.
Yeah.
That's the concept of detachment. If you lose, you lose. If you win, you win. In Sweden, detachment is lagom. It's not a big deal, either one. Take it easy, move on. Don't look back, look forward, and don't preoccupy yourself with the far future, which you have no control over. Just be in the moment and be detached. Yeah.
But moving to the concept of AI perhaps helping people.
Yeah.
BrailleTouch.
Yeah. BrailleTouch. Do you want to talk about BrailleTouch, or do you want me to talk about BrailleTouch?
If you would like to, given a slight description of it, I have something prepared, but I think the words of the person who's developed.
Yeah, so it's a team effort, and BrailleTouch was originally the idea of Brian Fry, a good friend of mine, and he was attending a talk where the latest research paper was comparing the text entry speed of the latest prototype with Apple's voiceover, basically the keyboard for voiceover. And voiceover is the accessible layer for iOS for visually impaired people. And you basically put your finger on a letter, it tells you what the letter is, and then you release. Because you can't see it. So you're scrolling, it's like A, S, D, F, G, and then you release. And you want to write something like great. So then you look for the R, and then you look for the E, and then you release. And it takes a minute to write a word. It's like to write your name, it takes a minute. So, that takes a lot of patience, but people with impairments, one of the superpowers they develop is superhuman patience and tolerance. So, they were dealing with this. And Brian attended this talk, and he's like, oh God, really? That's the state of the art? Because they had gone from 1 word per minute to 1.17 words per minute. And it's like, oh, wow. When you type on your keyboard, if you're a good typist, you can do 40 or 50 words a minute. If you're an excellent typist, you're pushing 70. If you're world record holder, you're doing like 200 words per minute. It's like crazy. And yet there are systems that where you can enter text even faster than that, not based on a QWERTY keyword. Other systems you can go faster. So he said, all right, that just doesn't make sense. And these were keyboards for the blind on mobile devices. So he thought, and it worked like this. It had a rotary wheel, and you had to find, for example, the group of letters A, B, C, and then go further and choose A, B, or C. So it was like a nested set of circles, or angles, and sections of a circle. And that actually worked faster than a QWERTY keyword for blind people on the phone, which is not surprising. But then Brian actually had an idea that leapfrogged. Like, boom! Because people were going from 1.2 to 1.3. You know, the stars of the field, of the research field, were pushing 4 or 5 words per minute. Ultimately, BrailleTouch would push 40, 50 words a minute if you know how to type Braille. So I'm giving you the spoiler. That's the end of the story. And what he did is, well, how do people type Braille? Let's go check. And people type Braille using Braille typewriters by chording A, B, C. So they press multiple keys at the same time, and the input is on the release. Because if you want to press a B, it's these two, and you can go first with the 1, then with the 2, and then you go up, and that's when B is typed. Because the moment going into the keys could happen at different moments, but going out of the keys happens at the same time. So it's on the release. So that's how you type Braille. And in the past, there were physical typewriters that could do this. In the present, there are digital typewriters with physical keys that can do this, and they're called Braille writers and Braille readers, because you can also pass your finger over a set of dots that are popping up and down, and you can read this if you know how, if you're sensible enough to read Braille and have learned the language system. The reading and writing system is not a language system. So Brian said, okay, so you got a 1x6 matrix of keys. What if you take that matrix and fold it into a 2x3? Oh, and then you can hold the phone and face the screen away from the user, and now you can type A, B, C. Will that work? Well, it did. It did work to the point that we blew everything else out of the water. And we, in the beginning, the keys were hard-coded. So there was a space for the 1, a space for the 2, a space for the 4. So it's 1, 2, 3, 4, 5, 6. Those are the keys, and their combinations give you characters and numbers. So in the beginning, we hard-coded everything, and people were making mistakes left and right. They still felt it was much better than anything before, but there was room for improvement. So we put in just simple pattern recognition, like super simple. I wouldn't even call it AI. But then again, when it works, you never call it AI anymore, right? So adapting to the patterns of people's fingers. So rather than hard-coding buttons on the screen, if it's a single finger and it's more or less in the area of the left index, that's a 1, regardless of where you're tapping. If you have 2 fingers and you're more or less on this side of the screen, that's a 2. And on top of that, Braille was designed by Louis Braille, and it's a fascinating story. The kid, 12-year-old, was smart enough to recognize that he couldn't read, he could only read one single dot Braille character, which was the A. Because when he was passing his finger over the written dots, he couldn't distinguish cell 1, 2, 3, 4, 5, or 6 if it's a single dot. It's difficult. I mean, even just knowing that this is a single dot is hard enough. Knowing where it is in the 2x3 cell is like impossible. So what he did is he reserved the single dot character for A, the 2 dot character for B, the 2 vertical dot character for B. So there are no other 2 vertical dot characters. The 2 horizontal dot for C. So he did it alphabetically. He didn't know enough to do it statistically. Like, what is the letter that people in French type the most, which is E. He should have gone with E for the single dot character, and Braille would have been a little bit faster for reading and writing. But okay, let's give him that. He was 12, didn't know enough of statistics. There's a single 3 dot character, which is L. So you take advantage of those properties of the system and you start doing classifiers that make fewer mistakes when people are trying to type an L. So we did that. So we started including some classifiers and this and that. And we created a system that worked. We won a design competition here in Stockholm in 2011. In 2012, we created a company, BrailleTech, and released BrailleTouch into the App Store. And our goal was for Apple or Android to take our product and include it into their operating systems, because we developed an in-app purchase of $20 for people to be able to copy-paste what they wrote in BrailleTouch. And we couldn't write directly into the text field of an email, for example, because then you needed access to the operating system, and we couldn't get it. Like third-party provider of apps, you can't get access to the operating system like that. So our goal was for Apple or Google to take the design and incorporate it into the operating system, and Apple did it. Like a few months later, they put us on the front page of third-party accessibility app providers. We were on top. It was like BrailleTouch is the greatest thing since warm bread. Visually impaired people were really, really good at getting information from their phones using screen readers, but inputting information to the phone was the bottleneck. BrailleTouch came in and poof, immediately removed that bottleneck for people who can type Braille. And that's a big if, because a lot of people lose their vision later in life, and because of all the devices that we now have, they don't become proficient in Braille, because there are many other ways to read and write than just Braille. But if you're born visually impaired or with low vision, part of your education includes Braille. It's just like, this is what you do. And it's complex enough that it makes a difference whether you learned it at 5 or whether you're learn it at 50. It makes a huge difference because it's like a language. And so Apple took BrailleTouch and iOS 8.0 introduced it into the operating system directly. So now you could change from a QWERTY keyboard that voiced what keys you were trying to type. You could go into the operating system and change the settings so that you would switch from a QWERTY to a Braille keyboard. And now you could enter using Braille. Boom! Of course, that meant we were out of business, so we closed BrailleTech. And we never protected the technology. We just left it open. And a few years later, Android followed suit and also incorporated a Braille keyboard that works just like BrailleTouch. But both companies moved it a step further. There's a system called contracted Braille, which allows you to type at 250, 300 words per minute and read. And it also compresses the thickness of printed Braille books, because contracted Braille is a formal grammar for abbreviating language. So there are rules. You can learn the rules, and then you very quickly pick up on thousands of words that are abbreviated. So Apple implemented contracted Braille. They implemented better predictive algorithms of what people are typing. They threw in their resources, and the Braille keyboard that is on iOS devices is a beauty. And we had a little bit to do with that. And the Braille keyboard that is on Android devices, I've tested it. I have Android, and yeah, it's pretty good. It's much better than what we could do with the resources we had. But we you know, Steve Jobs, put a ripple into the water and let it go. That's what we did with BrailleTouch. We put it there, and right now, with all the predictive algorithms for text entry, it will continue to grow with any keyboard, and not just Braille keyboards. But for visually impaired people, mobile devices have become almost as powerful as walking canes, because it allows them to have a voice and to have action and to have agency in a world that is increasingly digital. And they don't need to see images. So this is fascinating, to understand patterns and to understand statistics and to understand images, because more and more people are developing their websites and their content with accessibility layers that allow the reader to get verbal descriptions of what they're seeing or not seeing. And it also, this sense of what is the goal of AI. Nowadays, we're using crowdsourcing to provide prosthetic vision. But in the near future, the crowdsourcing is going to be complemented by AI, increasingly complemented by AI. So let's say this is a bottle of medicine and it has the prescription here and it has the indications and counterindications here. And I want to read, I want to read that, but I can't because it's in text format in a bottle. So I take my phone, I take a photograph of it, and I send it to the crowdsource. And there are people donating their eyes and time to go through the image. And if it's not readable because the illumination was not good enough or the camera was actually not focused on the near plane, it was on the far plane, they communicate with the user who's visually impaired and say, please make sure the lights are on. They may even text or even chat with each other. And orient the bottle this way, put the camera at such a distance, get a better photograph. Eventually they can get a photograph that is readable for humans, not for OCR, optical character recognition yet, because everything, the focus, the illumination, I mean, these are like CAPTCHAs, right? These images. But a human can read and translate what the visually impaired person took with their phone, what's on the bottle, and get a proper prescription and indication of how to take that medicine. Right now, the complexity of this task is high enough that we still rely on artificial intelligence, aka crowdsourcing. But I think that may start to very quickly go full AI. And humans will be able to see the world through the eyes of AI. And that means that visually impaired people will be able to see more, but it means that visually able people will be able to see more. More across time, more across space, more across cultures, across individual agendas and systems of values. So AI has the potential of increasing our capacity to see, even if we think we see. Again, visible light, very narrow. Non-transparent objects everywhere. Occlusion everywhere.
So there are some interesting questions there, but if we begin with the one about that we had in our previous conversation about not prioritizing money, do you think that AI might be able to help us find parallels there? Because you see that, I think Apple is quite actually exemplary in their work in accessibility.
Yeah.
But
they took the lead on the Braille keyboard much earlier than Google. Even though we talked to TV Raman. TV, if you listen, we talked to you. He was the head of accessibility at Google. We sent Thad Starner to represent BrailleTouch and put it in the hands of TV Raman. And TV Raman is a brilliant engineer, head of accessibility, and he is visually impaired. And he thought it was a gimmick. Google could have had BrailleTouch, and they could have protected it, actually. They could have put a patent around it if they wanted to. But they've no, this is a gimmick. Yeah, not for us. Thank you. Yeah, okay. I don't know if Apple put any patents around their Braille keyboard. I hope they didn't. But if they did, then Android is Google's having to pay.
But nonetheless, I mean, the end point, at least from the user's perspective, is that they have much greater accessibility to their devices now.
They've been working really hard on accessibility for a very long time. I know that. Apple has.
And I mean, because I kind of, as we mentioned, capitalism is a really relatively new human concept, but it kind of works to some extent in certain societies, not all, but trying to find parallels between it and ways of improving human quality of life, I think is kind of trying to hit your...
Okay. You know that example of somebody has an accident down the road and you stop to help? That is a very dramatic instance of the larger picture, which is not every human is born with the same possibilities and potentials. And as humanity, Do we all just individually run towards the goal, regardless of who was not born with the resources to do that? Or do we stop and just lift everybody and then run towards the goal, making sure no one is completely forgotten? I'm not saying that we all arrive at the goal at the same time. What I'm saying is that we don't leave anybody completely in the dirt and don't care about it at all. That's what I'm saying. Accessibility is an example of that, because millions of humans are born with fewer senses, different ranges of sensing. They are born with different actuators. I'm speaking robot language here. With different levels of actuation, loads they can carry or not, speeds at which they can run or not, thinking processes which they can master within just a few minutes or not. And we're all different. We're all different in size, in perception, in cognition. Don't even get us started on looks and just height and width and weight. We're all different. But we share an understanding. So non-pathological humans share an understanding that other humans also have desires and needs, and that they want to make a difference. They want to transcend the little time they have in the universe. They want to, it doesn't matter. It could be having kids. It could be writing a book. It could be painting a mural. But they want to transcend the very, very, very few hours that we have on this planet. What is it? A few tens of thousands, 100,000 hours? I don't know. We can do the math. But yeah, we could talk about it in hours, just to bring the point home. Accessibility is an effort to not let people fall behind for no fault of their own. So we should all be thinking about accessibility all the time. And we should all realize that we're all in an accessibility spectrum, because we can't all understand everything at the same speed that some other people can. We can't all run at the same speed that other people can. We can't all lift the same weight that other people can. So we are all in an ability spectrum, in fact. It's not a disability spectrum, it's an ability spectrum. And some of us are super able to do some stuff, and some of us are super incapable of doing some stuff. And it's multidimensional, it's super complex. So yes, accessibility is an effort to have universal design. That is, it should work for everybody. And that's actually a very hard challenge to achieve, and it improves the value and the practice of the designer. Designers need to be better if they want to design, if they want to follow universal design principles, if they want to target a wide spectrum of ability. It just makes them better. It's like putting a load on your back and then running a 5K. If it doesn't break you, it'll make your legs stronger. So you got to balance it, like everything else. You choose your battles, you choose what you can do, but if it doesn't break you, it makes you stronger.
But do you think that AI can, now that we are entering the age of AR and VR and XR, and maybe we are at the very beginning of the age of like human cyborg type of level of works. Do you think AI is kind of going to be able?
Oh yeah, AI is going to play a role at every interface, because just to give you a very concrete example, to be able to hold an item between your fingertips and turn it around, that takes a lot of intelligence. And I am not overestimating myself. It does. And it takes a lot of intelligence on my brain or your brain or whoever is able to do this. And if you lose some part of that network, which you don't even think about, most people don't even consider that to be intelligence, but it is. It is, trust me. Doing this is non-trivial. So I'm just taking my ear pods. Well, these are not ear pods. These are Samsung pods, and I'm just flipping it in different directions, using different fingers in combination with each other. If something goes wrong anywhere here, even at the level of my muscles, at the level of my neural connections, it's going to be a mess. AI can go in there, and we develop AI not to solve financial world markets, but to solve the fingers moving in coordinated efforts to be able to do the things that we take for granted when we have the ability. That's the thing. Everything that we're able to do, we take it for granted. It's the irony of humans. And this is absolutely non-trivial. This right here is absolutely non-trivial. And if I were to miss that, if I were to lose that, I would miss it horribly. An AI can go in here, so or here, wherever the necessity arises, wherever the link is broken. That's actually a beautiful use of AI, prosthetic limbs that can work together with your central nervous system to allow you to have the abilities that you took for granted before.
That's, I mean, my big dream in life, as I always said, like to say it in a slightly comical way, is putting chips in people's brains. But I mean, the reality of it is simply that it's a path of, in some ways, communication, and in some ways, improving like our capabilities. And
eventually, it may happen that we engineer ourselves, and in some ways, it's already happening. Through devices like this. It's just that we're still engineering it in such a way that we can choose to take it off and leave it there. I'm disconnected. Stay away from me for the next 8 hours, whatever. We may move towards engineering ourselves in a way that we cannot disconnect, and that's a fundamental change. But I think the precursors of that are going to be people that need it to accomplish everyday activities that most of us take for granted, like dressing themselves in the morning. It is those people that are going to get those bionic and AI prosthetics first, because all they're doing is just lifting their level of quality of life to an acceptable level, where they don't need help to get dressed, for example, which is of course very humbling, but it's not something that anybody would choose.
do you have any moral or ethical, do you think, aspects to that? I mean, one thing that I always think about is how AI is already improving people's lives in low-income and undeveloped countries in terms of like medical advice. But we have a risk assessment there. If the AI makes a mistake, makes a hallucination, it's still improving people's lives on the general basis. And
okay, so one of my engineering courses in undergraduate was antenna design, telecommunication antennas. And I don't know if you know this, I don't know if you've ever gone through the exercise of designing an antenna. You design it to work, you choose a number, and there are guidelines. So you design an antenna, like a microwave antenna, to work 99.75% of the time. That's actually pretty bad. 99.9975% of the time. Oh, now you have an antenna that can actually do something. Those numbers are crazy. I mean, if you think about a lot of the technology that we're currently using, that if they hit 80 or 90%, we're happy. Like, for example, dictation. When you dictate to your devices, I dictate to my phone regularly. I have to correct every 3 or 4 words, and my pronunciation is not that bad. In fact, I've recently started dictating and then sending what I dictated without correcting it, copy paste to ChatGPT, and I tell ChatGPT, hey, listen, I dictated this thing. I know it doesn't make a lot of sense. Could you please fix it? And it comes back and it's actually correct. So I'm using ChatGPT regularly as a layer between dictation and proper text. I do tell ChatGPT, do not add any concepts, words, or ideas.
for anyone who's received mails from Mario.
I tell ChatGPT, correct the language, correct the syntax, but don't add anything of your own. I mean, keep it. These are my words. Keep it my words. At least when I'm dictating. For example, a talk. I'm going to give a talk. I do a dictation, and I make sure that it is within the time allotted for the talk, for example. So then I would dictate, use ChatGPT for transcription, and then I use something called natural readers, which is another AI for text to speech. So I listen, and I set it at 200 words per minute, which is more or less my speaking rate. And if natural readers can read it within 7 minutes, which is the time that I have, all I have to do is now memorize what I just said. And there's no AI for that one yet. That's the chip in the brain then. But to come back to your question, so you were asking about, tell me the question again, please.
The question was basically the risk that we are willing to take with people, let's say, have impairments, and we are saying, regardless of how accurate this AI is.
Yes. So we can't do that. We don't design telecommunication antennas allowing them to make too many mistakes, like to drop the signal. We actually keep a very tight boundary on how many signals it can drop within a year, because otherwise it's not an operational antenna. It's not something we can trust. So we have to design AI systems to more or less follow the same rules. I also did civil engineering in my undergrad, and you design buildings to fail gracefully, which is another beautiful concept. You don't design fully rigid buildings. You design buildings that after a certain stress period, they collapse. They become like bubblegum, and they become like a fluid, allowing people to exit the building. So they don't collapse, they deform. So we should design AI that doesn't collapse. It deforms, and it allows us to see that something is wrong and take human action.
But let me make it slightly more challenging for you to answer then. Let's say we are talking about a very underdeveloped country, and we can give them AI models with all their faults at the moment, that with 85% of the time have accuracy in terms of like detecting a medical issue.
Right.
And 15% of the time they can give very bad advice.
Yeah.
And that's actually something that is kind of being tested out at the moment.
Yeah.
I mean, the numbers, of course, are just an example, but and I think those models are actually more accurate. But is it wrong that we are doing it?
Yeah, no. It's an ethical and moral dilemma, and it's more complex than that, because you have to take into account what is the context. So, okay, you introduce AI that makes mistakes 15% of the time. What is the alternative? What is the current rate of true positives being missed for cancer treatment, for example, or malaria, or cholera, whatever it is that is afflicting a society? You have to take into account the larger context. What is the alternative? How many people are dying if we do nothing? And unfortunately, it is a systemic decision that needs to be taken by people who are willing to live with the fact that they've decided to kill fewer people or let fewer people die. And that's a very difficult decision that not everybody's prepared to make. Because you have to, like we said with the gambler, you have to set your moral compass before you join the game. Are you willing to let 10,000 children die to save 100,000? I don't have an answer for that, not for myself. Humans don't know themselves until they're faced with the situation. So you shouldn't speculate with that. You should think about what is your system of values, what is your consistent set of morals that you can live with before you face that decision, and then go into the game. It's the same dilemma. So you created an AI system that's going to make 85% accurate predictions. You're going to go into a place with 10 million people. Okay, 100,000 are sick. Oh God, 15,000 may die because of this. Now you have to start doing the math and thinking, what is the alternative? What happens if we do nothing? What are the resources that we have? What contingencies do we have to take care of that 15% that AI will misdiagnose? Maybe it's an attrition. Maybe it's not an attrition, a triage, sorry. Maybe it's a triage problem where you put in the AI for the 85, you take the 15,000 people, and then you put humans on that to do a deeper battery of tests, to do not what we call a screener, which would be the AI. The AI does the screening and is pretty confident of the 85. The 15 is like, I don't know. It's like, this 15% may or may not be. Could you please take a look at that? And then you design a triage system where humans go in and but humans are expensive because there are a few of them and their time is limited, and they can't be translated, transported across the world in minutes like AI can. So you reserve your resources for those tricky cases, and maybe you have a shot of saving almost everybody. And that's responsible design. You design for the greatest possible good in the sense of saving people. You recognize that you can't save everybody, and you, within the resources that you have, you create contingency plans for those of whom the first system will not work. So, and of course, the more you move up this ladder, the fewer resources you're going to have, the more expensive a solution will be. Doing nothing is immoral. If you have resources, doing nothing is not the most moral choice. Let me put it that way.
And now perhaps moving to the last topic to discuss, which we have already a bet on. It's on the record. The accuracy is paramount to the highest degree.
Right.
And perhaps AI can help us actually become better at it.
Yeah.
Is AI in the operation rooms?
Right.
And its surgical uses.
Right.
So you work, sorry, just to give a preamble, you work with, at the moment, visualization of particles in the operating room.
Yes.
And also the different use cases of how AI can be implemented in ORs.
Yes.
So at what stage can we start, and what is the type of balancing that we have to do between allowing AI to take over and having human supervision? How much human supervision on that?
Right. So we had this conversation before. Human doctors are not willing to give up the control if they can help it. So if there's a human doctor in the room, they will not relinquish 100% of the control to any AI or robotic system. The reasoning is it has a lot to do with the Socratic oath and also the way that they think. And that is, you have to save the patient. So do no harm and do everything you can to have a positive outcome. That means if electricity goes out, if the network is down, if the sensors are failing, a human trained doctor, surgeon, physician needs to go in and do what is in their capability to minimize the damage, maximize the recovery. So robotic surgeons are okay as long as everything is working. But there will, in my opinion, for a very long time, there will always be a human ready to jump in just in case something fails. They're not going to relinquish 100% of the control to automated robotic surgeons anytime soon. And it has more to do with human nature than it does with technology. Now, let's say we've been, hypothetically, we've been using robotic surgeons at a success rate of 100% for 100 years. Will there still be a human there just waiting for the opportunity to jump in if something goes wrong? Well, in that case, in that specific scenario, I would actually wonder if the human knows what they're doing, because they haven't had enough practice. And it's a difficult question, because part of the equation is how much practice a human actually gets. And if the robotic system is not failing ever, which is a big if, then humans won't get a chance to practice, and that's scary.
I mean,
That's scary because the moment the robotic systems fail for whatever reason, we're back to the Stone Ages.
I think that's already happening in programming, though. I mean,
Yeah.
there are people who in the 90s coded everything in C and assembly and made games in assembly. And
In the 90s, we weren't doing assembly unless you were doing EEPROM, like a programmable memory.
I think John Cormack was kind of regarded.
The other reason why you would do assembly is because you wanted to optimize it.
Exactly.
A very, very repetitive piece of the loop. You wanted to optimize it to the maximum. So if you were in those situations, you would push out your assembly.
Yeah,
power.
that was his case of like wanting to make his games as optimized as possible.
Yeah. So it was either optimization or you were working with very limited systems.
Exactly. And now I mean, people, I think we see that in programmers, they are becoming dependent on co-pilots and AIs to improve their code. So we already see that happening in a branch that is perhaps not as sensitive as surgery, but it is a trend in society. And it's a question of, is that a good thing? Is that a bad thing? But
it's super interesting. You can certainly imagine a world where AI is super good at memory collection. So you just don't have memory leaks anymore because AI doesn't allow it. And that's a big win. Will AI produce code that is as efficient as it can be? Well, by definition, no. Because of NP completeness, there are some issues that not for every problem will AI find the optimal solution. It's just, you can mathematically prove that it won't happen. But you can also prove that humans won't do it either. So yeah, you have to know what you're talking about. You have to know where your expectations are. I think code readability is an issue, and I do think that we should ask AIs to write code that is humanly readable. And the fact that we have ChatGPT now is promising, because certainly ChatGPT can write code and document it in a way that humans can read it and maintain it if necessary, and debug it if necessary. I don't know the rate of bug introduction of something like ChatGPT, and that's sort of scary. But I do know the rate of hallucination. I mean, I see it every time I speak with it. If I rub a little bit hard, I can start seeing some hallucinations or just complete ignorance. But that's the thing. ChatGPT doesn't know whether it knows. It just doesn't know. So when it's ignorant, it doesn't know that it's ignorant. And when it comes to writing computer programs, there are many critical systems that depend so much on efficient, readable, encapsulated, documented, maintainable code that is correct and that is provably correct, that you can prove that it is correct. Everything from energy systems, medical systems, airplanes, we depend on code that doesn't break, and that can grow when it's and that you can prove that it can grow without breaking. So I think AI can support that. Again, whether or not humans are willing to trust AI 100% when flying a commercial airplane, I don't know. I don't think so. I don't think we're just gonna do the code for fly-by-wire for this jumbo. They're like, no, I think there's going to be due process in making sure the code is up to standards.
And how far, this is, as I like to call it, the last question of the podcast that I always ask, but how far do you think are we from a so-called AGI?
Yeah.
And how do we define it is a very big question, but let's just...
I call AGI the common sense engine. So the question is, how far are we from a common sense engine? The common sense of the big and the small things. Picking up these keys will produce sound, even despite my best efforts. That's common sense. So if I need to be super, super quiet, I can do so many things. There, lost. It's just going to produce noise. That level of common sense is far away from us right now for machines. But and the problem with general AI, it's that it's multimodal, it's interconnected, it's self-aware, and by definition, empathic. If it's not empathic, it's not general intelligence. It's lacking a very important component. You should read Theodore Sturgeon's More Than Human. If you're missing empathy, you're not there yet. And true, like, felt. When a parent sees their child get hurt, you've heard parents, oh, that hurt me more than you. It's a different pain. It comes up your spine and it lifts the hairs in the back of your neck, and then it sort of hurts you from the inside. There's nothing physically hurting, but it's a pain that you can't get rid of, especially if your kid hurt themselves pretty badly. It's a different type of pain, but it is mirror neurons in your brain pulling a full, ninja level event in your cortex, and there's nothing you can do about it. You feel the pain, and that's empathy at its greatest. And we're nowhere near that for machines. Like we said at the beginning, right now they're just matrices that are being multiplied and stacked and added and subtracted. There's no empathy in there. But I don't want to rule out the fact that maybe we can simulate, model, and make an entity that behaves in empathic ways, together with all the other elements of general intelligence, that at the bottom of this, a very complex model, at the very bottom of it, it's just bits flipping up and down and matrices being multiplied left and right. And we're back to the topic of transduction, or the topic of photosynthesis. When you go deep, 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 yeah, it's just atoms, molecules, quanta, that is flipping back and forth. But it's happening so quickly, the complexity is so high that it has an emergent systemic behavior that is indistinguishable from common sense.
On the note of the very beautiful systems that we kind of don't still understand, I think I would like to thank you very much for being part of this interview.
Thank you.
And attending the podcast. Thank you very much, Mario Romero.
Thank you.